Ladies and gentlemen, welcome to an edition of Tekken 10 with me, Steve. Today I'll be looking at the X99-Extreme6/AC from ASRock. Now, this is a pretty feature-packed board. It is of the X99 socket, LGA 2011-V3. You can't toss a Sandy Bridge or Ivy Bridge CPU in this. Haswell only, or Haswell E only. Anyways, dual NICs, wireless AC card. By the name you can tell. There is also a 3.1 version /3.1. It doesn't come with the AC card, but it does come with a USB 3.1 card as well as a port on the back. I'm not going to talk about that board anymore. Maybe in the future I'll give you a little overview of that, but today I'm taking a look at this one. This blue beauty. Anyways, we can't really find many blue motherboards these days because, well, it's become a novelty. It used to be on everything, right? You turn left and right, every manufacturer had a blue motherboard. Nowadays, it's becoming more of less unlikely occurrence to see blue motherboards, which is, in my opinion, kind of sad. There are a lot of blue accessories. Blue is a nice color. When you see blue, you think peace. You see red, you don't. You see black, you don't. Blue, I mean, is one of those colors that seems to calm people down. I mean, but when you're talking about a high-performance game PC, calming is not really some people's thing. So there's blue motherboards for some of us, and there's red for others, and there's yellow, all types of colors. Spectrum of the rainbow. If there's a color, probably is on a motherboard. Anyways, so let's take a look at this board. We have a nice VRM cooled by a nice heatsink, PCH heatsink. Now, we're done looking at the heatsinks, right? I can just take them off. Alright. I've already unscrewed them for you. You know, who wants to stay there and watch me unscrew heatsinks for a minute and a half? I don't know. If you do, I mean, let me know. I don't really want to, though. I've taken this off before. That's why it might not be perfect, but contact is excellent. And metal screws hold on everything. You might notice there's nothing being cooled on this side. So when it's like this, it's not really cooling anything on this side of the motherboard. That is because it's just used to cool down the CPU, VRM. That's it. That's all it does. Big heatsink, but it does an important job. Anyways, PCH. The reason the heatsinks are like that on X99 is because of the fact that the area for the VRM has been cut in half compared to previous previous motherboard area for VRM, so motherboard VRM real estate is cut in half. On top of that, power draw on the CPU is basically doubled, so you basically need to provide double the amount of cooling you would in the past, if not more or less, depending on the MOSFETs, of course. Everyone's using high quality X99 though. PCH, contact good, metal, all good. Anyways, let's take a look at this. So, let's zoom in. Is it too close? No, that's actually good. Okay. So you got a lot of stuff here. Actually, I probably need to rotate the board so you can see all the phases and stuff like that. Okay, first thing off the bat. Actually, maybe I should go over this stuff. Well, actually, I forgot to do something. Let's go over the I/O, okay? The back panel I/O is right here, and I'm going to zoom out. Don't be afraid. Don't be afraid. Alright. So, we got two USB 3.0 here, 4 here. This comes from an AS Media controller directly, and this comes from a 1-to-4 hub from Intel. Anyways, there's eSATA here, clear CMOS here, two USB 2.0 PS2 keyboard or mouse, and we have a Toslink here, which has the optical or digital SPDIF out, and yeah, your standard output, 7.1. Oh, and dual NICs, and one of them is Intel, and one is ASRock's Cloud, which is basically Atheros. Qualcomm Atheros, I should say. They're the same guys who make the killer NIC. Okay. Anyways, I'm gonna zoom in a little bit more actually. A little bit less. Sorry, I should really get a cameraman, shouldn't I? Alright, let's go over what powers the I/O USB, because we're seeing the USB there, and I told you it comes from AS Media controllers. First of all, we have an ASM on the right. There we go. This is an ASM 1042AE. It's a USB 3.0 controller. One PCIe lane is routed to it, and out comes two USB 3.0. This, on the other hand, is a ASM 1074, if I'm not mistaken. And the ASM 1074 is a 1-to-4 USB 3.0 hub. And so basically, one Intel port is routed here, and the Intel port is changed into 4 USB 3.0. This is one of the memory VRs, okay? and it's 2 phases. I'll go over that after I go over its controller. So we have 2 controllers here, and they're both identical. There are actually 3 of these bad boys on the motherboard. They're ISL6379, which are 6+1 digital hybrid PWM. So they're analog digital hybrid. They're digitally controlled though, if that's important to you. Anyways, there's 2 of them. Basically, one is really going kind of to waste because a lot of its phases are not being used. So this is a 6.1 phase PWM. Only 2 of those phases are being used. They're going directly to the 2 memory VRs here, and then another one of these on the other side is doing the exact same thing. So it's going there, and then those are powering the main DDR voltage. There is also a DDR VPP, and I believe that's being powered by this chip here. Now, I do have the model number on this. It says like MPDM, something like that. It's a POL device, a point of load, and it provides up to like 15 amps or something like that. Very high. That's for the VPP. It's not very important, even for overclocking. But yeah, so this is the main DDR voltage, and it's powered by Fairchild Semiconductor FDMS 3668, if I'm not mistaken, which has 13/18 amp output for the high side and low side FET at only 2.5 watts. So when you hear about like 60 amps, stuff like that, that's at like 11 watts on higher end stuff. Of course, it's not a linear progression, so you can't just multiply 2.5 by 4 and multiply the output by 4. It's definitely, heat output is definitely, why can't I think of the word? Exponential. So yeah, you kind of have to calculate it out or actually go and test it out. But these are actually very high quality, and they're pretty good, and they're dual N channel FETs. You only need 1 per phase because it has the high side and it has the low side in there. And the VRM, main CPU VRM, 12 phases, getting 6 of those phases from the PWM, and it also is using those exact FETs. So yeah. So it's very high quality, and this is ASRock's 1300 watt, so 1300 watt output VRM. In terms of that, they're taking 1.8 volts, multiplying it by 60 amp per phase, so 1.8 times, whatchamacallit, 60 times 12, yeah, should be basically 1300 watts. Well, no, you take that. Yeah, okay. Because the output P equals IV, it's a deviation from Ohm's law, and that's for perfect ohmic resistance. So it's not really perfectly perfect, but they can advertise 1300 watts because it maximum potential output could be 1300 watts. Anyways, it's a 2 or 3 types of capacitors on the output filter. This is meant to output, like filter out the high and low frequency noise. These are normal polymer capacitors. However, these are highest rated in the business I've seen so far. 12K Nichicon gold capacitors. Most everyone else is 10K, which is very high, but 12K is just higher than the rest. And ASRock gets props for that because they're using them on all their boards. So this is a mix of different types. It's pause caps, it's tantalum solid, they're 330 UF each, and these are 560 UF each from Nichicon. And these pause caps are from Panasonic. They're the brand name tantalums. And then you have a bunch of these little ceramics, and these are multi-layer ceramic capacitors. They have a very minuscule output, but they filter out a lot of the high noise stuff. Okay, or high frequency noise. Anyways, just a single 8-pin, not such a big deal. Here we have a USB DOM connector. This is internal USB 2.0 port, and what this is for servers and stuff like that. Because very high-end software doesn't use the digital right management that our low-end software use, like Photoshop. You put in a key, you validate it, you authenticate it, boom. Photoshop doesn't cost that much. But there are software programs out there that cost not hundreds of thousands, but like tens and thousands of dollars. High-end business software, and their keys come on USB sticks, and they have to be present for using the software. And that's why many servers or workstations might implement this software, and why USB DOM would be convenient, because USB ports are inside the computer and not outside. So people can't just like yank it out, or it won't be taken out by accident, stuff like that. So that's why this type of port exists. I guess for overclocking it's useful as well. If you want to overclock on a test bench. Then we have the same VRM for the memory over here as we do over there. 2 of those same FETs, and then this is the VPP supply. Okay, let's move the board a little bit. I don't want to really move the camera. 2 USB 3.0 headers directly from the PCH. I believe 5 lanes from the PCH in total for USB 3.0. And 4 of them go here, and the one to the back panel for the hub, and then one PCIe is changed into 2 in the back panel as well. All these SATA ports are from PCH. There is no third-party SATA controller on this motherboard. Yay! Okay. Going over here, there's some OC features. Postcode display, critical. HDD saver is ASRock's little thing where you can use the UEFI to basically disable or enable SSDs. So you plug a special adapter provided with the board, you plug it in here, and you're able to control the power and cut off power to SSDs, or I guess HDDs as you like. Power and reset buttons. Okay, front panel header. Yeah, let's move on. I should mention that some of these SATA ports are shared. One of them is shared with the eSATA on the back, and one of them is shared with the Ultra M.2 connector, so that you can use SATA-based drives in it. And I'll explain that in a second. This is a TI NextFET, this little silver thing, and that's for the power for the PCH. I'm not off the top of my head, I don't know the model, but it's like maybe CDMS 8515, something like that, I don't know. This is the Super I.O. It's a NCT6791D. It is very common. I believe my previous review is also using the same, from another manufacturer using the same one. Dual BIOS ROMs. These are 128 megabits, 16 megabytes, and they're in DIP sockets. You can remove them and send them back to the manufacturer if needed, and this switch here switches between the two of them. Okay. This is a, I believe, mini PCIe slot, or maybe it's M.2 key slot. It doesn't matter. It uses one PCIe lane. And it has this AC controller. This is a Azure Wave BCM94352. It's actually pretty fast, and it provides BT 4.0 as well as 2x2 wireless AC, which is 866 or 67 if you like to round up megabits per second. 866.6666, which I guess some people put 7, or you just round up because over 5, right? 0.5. Sorry, that was too much math in too little time. This is Ultra M.2 slot. Now, let's go over the PCIe allotment because that's important. Okay, so there are not many PCIe quick switches around. There is one here, and I believe there are 2 here, or down here on the other side of the motherboard. And these two switch PCIe either to the Ultra M.2 slot or to this last 8X slot. Okay, so if you use Ultra M.2, technically the entire slot will be disabled. That's in the manual. That's what the manual says. Otherwise, these are 16X wired, 16X wired, 8X wired. This is with a 40-lane CPU. I'm not going to go into the crazy stuff with the 28-lane one CPUs, but it's in the manual if you're interested. 16X, 16X, 8X, 3-way, 16X, 16X, 8X. These two never downclock. There's no need for them to do it. But let me tell you this: if you're populating M.2 drive, this slot's disabled. Okay, so if you're M.2, you can't do more than 2-way graphics cards on this board. That's just how it is. It's a limitation of the platform as well. If you want to use PCIe 3.0 for M.2, which makes the Ultra M.2 32 gigabits, rather than using 4X PCIe 2.0, which would only give you 20 gigabits per second, then you basically have to take some of the CPU's PCIe lanes and route it to Ultra M.2 slot. Now, there are 2 types of M.2 devices. There is the PCIe based, and there's SATA based. So basically, M.2 is basically storage protocol that can use PCIe or SATA. Now, SATA will require SATA link to the PCH. That's what this little chip does here. This is the ASM 1456. Well, actually, I'm not sure. Either that or this ASM 1480 will switch one of the SATA ports, SATA 3_3, to the back panel for eSATA, and the other one will give one of the SATA ports, I'm not sure of the number off the top of my head, to the M.2 slot just for a SATA link. Anyways, that's what these random 2 switches do right here. Other than that, this will support both, but there are many cases, especially if there is a PCIe slot that only hooks up, or M.2 PCIe adapter that goes, you install the M.2 card into a PCIe card and you put it into a PCIe slot, that won't support SATA-based drives. So this is kind of important if you're buying a M.2 drive. All the fastest M.2 drives, let me put it that way, like the Samsung XP941 or 951, I forget the exact letters before them, but the 941 and 951 from Samsung, which have incredibly fast speeds, they're all PCIe based. There's no reason to have a SATA uplink for those. But a lot of like Intel based ones can have a SATA link. A lot of them don't. So it's pretty much random. This is an extra clock gen that provides a 100 megahertz clock bus for the big slots. There are also 2 little slots here, and they're 1x from the PCH. So they're PCIe 2.0. Okay. Now let's zoom in. There are a bunch of Nichicon gold capacitors here, and the reason manufacturers are using these gold capacitors is because they have liquid inside and they're electrolytics. They're not solid polymers like the normal capacitors we're seeing, which is great for digital domain. But for analog domain, they find that these gold Nichicon electrolytics are better than the solid ones. Of course, there is always a need for like solid caps. It all depends on the ESR and ESL and different qualities of the capacitor. Better and lower is not always better. Well, lower is not always better. Anyways, these are dual NE5532 Texas Instruments amplifiers for the audio from the ALC 1150. Okay, one for the front, one for the back. So both the front and back panel outputs are amplified. Okay, moving over here. Oh, we're almost done, right? This is an Intel NIC, an i218V, which is basically the physical layer device for the Mac in the PCH. So it works with the PCH to output 1 gigabit. And it's actually a very good NIC. A lot of people like it. This is a Qualcomm Atheros QC-A8171. And many people attune this to be almost basically the same as Killer E2201 or Killer E2205. It's basically the Qualcomm Atheros NIC without the software that makes it a killer NIC. Okay, and you can actually see that ASRock had kind of planned to maybe put a cover on this if they used the killer. That's what these little slots are here for. I'm not sure. I'm just speculating. But you can see the PCB divide. You can see through the PCB. And this removes helps isolate the analog from the digital domain of the rest of the board, because audio outputs are analog. Alright, so I think that's really it for this board. X99 boards are kind of easy because extra Molex receptacle for power for your multi-graphics configurations. Really only like 3-way SLI would need this, or even 4-way I believe it's usually required, because you don't want to burn out the 24 pin, because there's only so many 12 volt wires in the 24 pin. Anyway, so that was the Extreme 6 X99-Extreme6/AC, and I hope you enjoyed it. Alright, come back for more later.